So, very good evening to all. Am I audible?
Yes, sir.
Okay. So, before I start the discussion, those who are new to this session or those who have not attended the previous two sessions, I want them to please introduce themselves.
Good evening, sir.
Yes.
My name is Akshay Kumar Sai. I am from Odisha. And I am currently pursuing my MCA, second year student.
Okay, very nice.
That's
Okay. Okay, Akshay. Anyone else?
Hello everyone,
Yes, Abni.
myself Avni Putri. Yes, sir. Myself Avni from SGS ITS Indore. Currently, I am in my final year of BTech. Thank you.
Okay, very nice. Others?
Yeah, good evening everyone. I am Shivam Kumar and from Aligarh, Uttar Pradesh. Currently I am pursuing Master of Computer Application from Banaras Hindu University.
Okay,
Yes,
very
sir.
nice. Anyone else? Anyone else who wants to introduce? Can please unmute and introduce. Okay, fine. So I'm starting the discussion. Let me present the slide. So is my slide visible?
Yes, sir.
Oh,
Yes, sir.
okay, very nice. So let me start. So this is the week 3 discussion of this subject, introduction to soft computing. This subject is taken by Professor Devasi Samanta of Department of Computer Science and Engineering, IIT Kharagpur, and myself, my name is Ayan Paul. I am a PMRF research scholar from IIT Kharagpur. So we have already conducted last 2 week discussion on Tuesday, and today is the third week of this discussion. So so last 2 week discussion, you all got the links, right? YouTube link as well as that slide link, presentation link, right? Okay, okay, very nice. You can all reply in chats also. In between, if you want to say anything, please reply in chats also. Okay, so, Anurag Raj is telling no, sir. Okay, kindly share. Anurag, if you open that NPTEL portal, Anurag, are you there? Hello, Anurag.
Yes, sir.
Yeah, if you open that
Yes, sir.
NPTEL portal where that week 1, week 2, week 3 lectures are shared, right? So below that you will be having a section called problem solving sessions. Okay.
Yes, sir.
Okay, so there you will find a Google sheet. There you will find all the links of week 1 as well as week 2 as well as today after this class week 3 also.
Thanks.
Okay, very nice. So let me start the discussion. So application of fuzzy sets. So till now what we have discussed is introduction to soft computing and then fuzzy theory. But today we will be interested in application of this fuzzy sets. Excuse me, someone is joining. Okay. So application of fuzzy sets. So what are the applications? First application is reasoning tool like fuzzy logic controller. This we will discuss in detail. Second is fuzzy clustering. Clustering means grouping of data points. We have many data points, and in tool like in subjects like machine learning or anything, when we are applying data to algorithm, what we want is we want to form a group of same type of elements. So there we do this clustering. And what is fuzzy clustering? Fuzzy clustering means a data point can belong to more than one groups. Fuzzy means as you all know, fuzzy means uncertain, or vague means there is no fixed boundary. So this data point can belong to more than one group. This is known as fuzzy clustering. Third is fuzzy mathematical problem. Fuzzy mathematical programming. So in this fuzzy mathematical programming, in mathematical programming like linear programming, you all know, you what you do is you form some relationship in the form of some bar charts or some other type of charts, and you are interested in finding the cost of the operation or etc. But you all know that in real life these operations are not that precise. This operation are fuzzy in nature. So we add this fuzzy theory in this mathematical programming, and this becomes your fuzzy mathematical programming. And fourth is your fuzzy graph theory. Again, graph theory, you all know, you always make graphs on different things. And again this fuzzy theory is added in this graphs to form this fuzzy graph theory. So these are your four applications of fuzzy sets. Excuse me, someone is joining. So out of all this application, fuzzy reasoning, also called fuzzy logic controller, is an important application, and we will read about this fuzzy reasoning, fuzzy logic controller in detail. So I hope this slide is clear to all. Application of fuzzy sets.
Yes, sir.
Okay, you all can write in chats also, and I want this class to be interactive. So I will also understand where is your doubt. So everyone please write in chats. If I ask you something, please write in chats. Okay. I hope this slide is clear to all. Okay, very nice. So let's move on to the next one. So fuzzy logic controller, as I already said that we will discuss this fuzzy logic controller in detail. So this is the diagram of flowchart of fuzzy logic controller, and in this you can see different things. So I will explain one by one in detail. So this is where you feed your input data. Input data is also known as antecedent data, and with this first module is your fuzzification module. So in fuzzy set, you all know this is some fuzzy set, and here you got your elements, that is x value, and here you got your membership function. So after we get our input variable, what this fuzzification module will do is it will convert your elements to get a membership function. Means like you got x star here, somewhat like here. So you can find the corresponding y value or the membership function for this. So fuzzification module do this process. This will be your mu star. Someone is joining. So this is your mu star. So this is the work of fuzzification module. Then in the previous class I have discussed fuzzy implications, right? Fuzzy implication or fuzzy rule. So there will be many fuzzy rule related to this fuzzy inputs. So fuzzy inputs or fuzzy membership function. So this inference engine will fire a particular set of fuzzy rule, and this is the work of this inference engine. So fuzzification module is clear and fuzzy inference engine is clear. Now after this fuzzy inference will infer from some certain fuzzy implication or fuzzy rule, we will go to the defuzzification module. In this defuzzification module, here in fuzzification, what we have done, we have find u star means mu star from x star. That is, we have found the membership function from element. Here what we will do is, we will find x from a membership function, means it is reverse of this, opposite of this fuzzification module. So you after this inference from fuzzy rule, you will get some mu star. From this mu star, you will get from defuzzification module, you will get x star. This x star is also called as output variable or your action variable, and this output variable will be fed into this controller, and your process will be completed. So this is what it is, and again I am telling you the steps. First step is, yes, identify input variable and output variable. Input variable also called antecedent variable, output variable also called action variable or consequent variable. Second is fuzzification, already discussed. Input variables converted into appropriate fuzzy sets. Third is inference engine. Inference engine evaluate the control rules stored in fuzzy rule base. And fourth is defuzzification. Fuzzy output is again converted into your crisp value. So this is the total working of fuzzy controller. So I hope this is clear to all. Anyone with any doubt in this, please ask.
Sir, why do you get fuzzy rules, sir? All the fuzzy rules?
What again tell?
Where do you get all fuzzy rules, sir?
Okay, so you are telling where will you get this thing, right?
Yes,
Fuzzy
yes, sir.
rule base. See, fuzzy rule base is already in your in your controller. Controller itself, there will be fuzzy rule base. In a fuzzy rule base, there are two things. One is called a database, another one is called rule base. So in database, you will be putting all your inputs, and in your rule base, there will already be fuzzy rules. Okay, so in detail, I will be discussing two numericals based on this fuzzy logic controller. There you will understand in detail. Okay.
Yes, sir.
Okay. Anyone else? Any doubt? Please ask. This is the basic of fuzzy logic controller, and I want this to be clear to all. Okay, so no doubt, right? Okay, so let's move on to the next one. So there are two forms of fuzzy logic controller. One is known as linguistic fuzzy modeling, and another one is known as precise fuzzy modeling. So what is this linguistic fuzzy modeling and precise fuzzy modeling? Linguistic. Linguist means related to some term, right? Term can be your right, term can be your left, like you are moving a robot. So there you are interested, the robot will go where, right, left, or where. This is known as linguistic fuzzy modeling. Here we are concerned with some terms, right? So this is known as linguistic fuzzy modeling. Another one is known as precise fuzzy modeling. In precise fuzzy modeling, like in our robot example that I have given, the robot have to move where. So in precise fuzzy modeling, you will get precise value, like 10 degree east, or like east. You can start with east. East means on the right side. So east, if you are starting with positive, like 10 degree positive or 20 degree positive. 90 degree positive means east to south. Then after 90 is like 105 degree, that means it is actually 15 degrees south. Or you, in this precise fuzzy modeling, you will be telling 105 degree. So this is the difference between linguistic fuzzy modeling and precise fuzzy modeling. Linguistic, again I am telling, linguistic fuzzy modeling deals with some term. Linguistic means it will deal with some term like right, left, etc. Precise fuzzy modeling, it will deal with some value. So what are the characteristics of this linguistic fuzzy modeling and precise fuzzy modeling? The characteristics of linguistic fuzzy modeling is it has high interpretability. Like if I will ask you to move right or to move left, so you will have more interpretability. Means your brain will process that information straight away, but you will have low accuracy. You don't know how much right you have to go or how much left you have to go. So this is linguistic fuzzy modeling. On the other hand, precise fuzzy modeling. Precise fuzzy modeling, it has low interpretability. Like I will tell you move to 105 degree. So you will not understand automatically that it is 15 degrees south. You will have to do the calculation and means processing, and then you will understand it is 15 degrees south. So it has low interpretability, but it will have high accuracy. When you will calculate this, so you will be very accurate, like you have to go to 15 degree south. So these are the two forms of fuzzy modeling. So I hope this is clear. Hello. So any doubt regarding this slide? This is one of the most important slide of fuzzy logic controller. So again I am requesting, if anyone has any doubt regarding, okay, Shivam Kumar is telling no. So Shivam, can you unmute yourself and ask where is your doubt?
No sir, I say I don't have any doubt.
Okay, very nice. Anyone with any doubt? So again I am telling, linguistic fuzzy modeling will have high interpretability and low accuracy, whereas precise fuzzy modeling will have low interpretability and high accuracy. Excuse me, someone is joining. Okay. So I hope this slide is clear to all. I am moving to the next slide. So now what will, last slide I have forget to tell you, the example of linguistic fuzzy modeling is known as mamdani approach, and example of precise fuzzy modeling is known as takagi and sugeno approach. So when we are putting this fuzzy logic controller and do linguistic fuzzy modeling, it is known as mamdani approach. And we are putting this precise fuzzy modeling in fuzzy logic controller, we call it takagi and sugeno's approach. So in the next slide, from the next slide what I will do is, I will solve one question of mamdani approach and I will solve one question of takagi and sugeno's approach. So it will help you to have a clear understanding. So this is the first example. It is based on this mamdani approach or linguistic fuzzy modeling. So seeing the question at first, you can have some fear because it is a one-page question. But I promise you, this is a very simple question. If you go with step by step, it will be very easy to you. So what this problem is considering, it is regarding navigation of mobile robot. So this navigation of mobile robot, we are starting, our mobile robot is someone at this S point, and we have to go this G point, and going this in the question given obstacle 2, this obstacle O2 is found to be most critical one. So what we want to do, we want our robot to escape this obstacle, to generate a collision free path for the robot. So in doing this, we have two inputs with us. One is distance between the robot and obstacle, D. So first input is D, or distance between robot and obstacle. So this is our first input, and our second input is the angle GSO for the motion planner, or this is the G and S. S is connected to G by a straight line path, and second input is our GSO, means how much the robot will take the angle. So this is our second output. So this is our second input. So again I am repeating, we have two input. One is distance between the robot and the obstacle, and second how much the robot needs to move to, how much angle the robot needs to move to avoid the obstacle. These are your two inputs. So one is D, another is angle GSO2. These are the two inputs, and these inputs are given, and this distance input is given in 4 linguistic terms. One is very near, very near denoted by VN, near denoted by NR, far denoted by FR, and very far denoted by VFR. So again I am telling two inputs, distance and angle GSO. Now distance has 4 linguistic input: very near, near, far, and very far. Similarly, our next input, angle GSO, has 5 linguistic terms, that is ahead, left, ahead left, ahead left, left, ahead right, and right. So these are our linguistic terms, as well as the output variable. Output is your deviation, means how much your robot has to deviate, and your output also has same 5 linguistic term as your angle variable, that is ahead, ahead left, ahead right, and right. So is the question clear to everyone? Shivam Kumar is telling no. No, I think it is a previous message. So is this question clear to everyone? Yes, Akshay Kumar is Swan is telling yes. Anyone who has doubt regarding this question? This is one of the most important questions. So again I am telling, please ask doubt if you can't understand it. Until you understand. Pralaya Parida is telling no sir. So Pralaya, you don't have any doubt, or you have doubt? Pralaya, no doubt sir. Okay. Anyone else? Any doubt regarding this question? So in simple, again I am telling this question. You have a mobile robot, you have two inputs, one is distance and the one is angle GSO2. Distance have four linguistic terms: very near, near, far, and very far. And angle GSO2, that is your second input, has 5 linguistic terms: ahead, ahead left, left, ahead right, and right. Similarly, you have one output. Output is known as deviation, and this deviation also have 5 linguistic terms, same as your angle, that is ahead, ahead left, left, ahead right, and right. So this is your question. So I hope this is clear to everyone. Now moving to the next slide. So this is given, this fuzzy sets are given. So in this question, fuzzification has also been done and given to you. So I am putting a line. This distance and angle are your inputs. This one is I1 and this one is I2, and this is your output. Deviation is your output. So distance and angle are your input, as I have told, and deviation is your output. Again, you can check this I1 has 4 linguistic terms: very near, near, far, and very far. This angle has 5 linguistic terms: left, ahead, right, and right. Similarly, deviation also have 5 linguistic terms, same as your angle. And your rule base is also given to you. So fuzzification is given as well as your rule base is given to you. And as this is a mamdani approach or linguistic fuzzy modeling, the solution of this rule is again a fuzzy again a linguistic term. That is why it is known as linguistic fuzzy modeling. In the next approach that I will discuss, there this rule will be in a statement form. So here, as it is the rule, the inference of the rule is in linguistic term. This is known as fuzzy linguistic modeling. So explain you the rule. So this rule is telling if the distance will be very near and angle will be left. So we will get a deviation as ahead. So you understand this rule base, right, everyone? Can I get a response? Hello? Am I audible?
Yes, sir, you are audible.
So this rule base is clear, right?
Yes, sir.
Like every rule from I1 input, this is your I1 input, and this angle is your I2 input. So every I1 input, when will infer with I2 input, you will get a deviation, and deviation is given in a linguistic term. So when you will fuse very near with left, you will get ahead. Similarly, if I take this one, if we fuse very far with left, we will get ahead term. So this is given to your question. So fuzzification is also given, as well as this fuzzy rule base is also given. Now what they have asked is deviation for set of inputs. If distance they have given 1.04 meter and angle they have given 30 degree. So they are asking what is the output in the form of deviation, that you have to calculate. So this is your question. The question is of 2 pages, but don't get afraid, because solution is not that difficult. So we are starting with the solution part. Solution, see, we have given 2 inputs. Distance is given 1.04 meter and angle is given 30 degree. So here you can see distance 1.04 and angle 30 degree. So when your distance is 1.04, you see this diagram, right? So distance 1.04 will be between this 0.8 and 1.5 meter. So it will be somewhere like here. It will be somewhat like here. So your input will be shared by 2 linguistic terms. One is this near thing and the one is far thing. This is clear, right? Hello? Hello? Am I audible?
Yes, sir.
So this thing is clear, right? If your distance is 1.04 meter and 1.04 will be lying between 0.8 and 1.5, that is, it is lying between 2 linguistic terms, near and far, NR and FR. This is clear to all, right? Yes, Akshay is telling yes. Okay, I am assuming this is clear. This is a simple thing. Still, I want everyone to clear this. So, so what we will do is we will take one triangle. We will take near triangle first. So, if we take this near triangle and we have this near triangle, this have extreme end as 0.8 and 0.5. This triangle 0.8 and 0.5 are the extreme end, and we have our input 1.04. So in fuzzification, as I have already told, in fuzzification you are interested in finding the membership function, that is y value. So you have 1.04. Yes, at 0.8 your membership function value will be 1, right? And at 1.5 your membership function value will be 0. So what is your membership function value at 1.04? So you can find out by this, that is x by 1 equals to 1.5 minus 1.04 by 1.5 minus 1.08. So you understand it, right? We are solving this by similarity of triangle. We are taking this triangle, small triangle, and this big triangle. So the small triangle x by corresponding element of x of a smaller triangle with corresponding length of x of this larger triangle is x by 1. And second, we are taking this value, that is 1.5 minus 1.04, and corresponding value 1.5, larger triangle 1.5 minus 0.8. So you will get a membership function corresponding to 1.04 as 0.6571. This is clear, right? Hello? Is this clear to all?
Yes, sir.
Okay, very nice. Anyone having any doubt? Please ask. Okay, so I am assuming this is clear. So you got a membership function related to this nr. So you will write mu nr for this distance variable as 0.6571. Now how you will find this 1.04 is also shared by this far linguistic term. So how you will find, you got this mu nr. Now how you will get mu fr? You just do 1 minus mu so what you do is you do 1 minus mu nr to get mu fr. So you can get two membership function, one is mu nr and there is mu fr. So similarly you do for your angle thing also. So your angle given is 30 degree. So 30 degree is between this minus 45 degree and plus minus 45 degree and 30 degree is between 0 degree and plus 45 degree. So again you have two triangles. One is again you have two linguistic term. It is shared between A is ahead and ART, ahead, right. So again you will do similar sort of calculation, and after this calculation you will get value of mu nr, mu fr as well as mu a and mu art. So I hope this slide is clear to all. How we found the membership function?
Sir, when you calculate membership function at 30 degree.
30 degree, very nice.
So
Yes.
mu of A first calculate, then after same manner we will minus 1 minus.
Yes. You will take this triangle, A triangle. This triangle you will take. You got it, right? A triangle you take. You calculate the mu A, and after that you do 1 minus mu A to find the mu ART.
After calculate mu of A, then we will calculate 1 minus mu of A, then I will get another.
Then you will get mu ART.
Yes, sir.
Okay, so mu A calculated here is 0.33, and you do 1 minus 0.33, that you will get 0.67.
Yes, sir.
Okay, very nice. So I hope up to this, sir, is the output change if any change in angle? Yes, definitely the output will change if you change the angle. Shivam, can you unmute yourself?
Yes, sir.
Yes, what is your doubt? Can you please ask? I
Sir,
didn't.
sir, there is an angle 30 degree. If
Yes.
angle is a 60 degree,
Yes.
60 degree, then how will we calculate it?
Yeah, yeah. So angle is 60 degree. So 60 degree is between what word? Which two linguistic term? Shivam?
Yes, sir.
Which two linguistic term? Your 60 degree will be?
Like 1.5 and 2.2.
No, 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 no. 60 degree angle thing, na? This 60 degree is your I2. I2 is angle. You see the bottom figure, angle figure.
Yes.
You say which between which two terms 60 degree will be shared.
I think, sir, there is no 60 degree.
45 and 90.
Yes, 45 it will be shared between 60 will be somewhere like here, na? So it will be
Yes.
between 45 and 90 degree. That is, it will be shared by two linguistic term, ART and RT. Okay, Shivam?
Yes, sir.
Shivam, if we have minus 30 degree, which two linguistic term will be it will be shared between which two linguistic term? Minus 30 degree?
Minus 90 to minus 45, like L,
No, no, no,
and
no, no.
AL.
Minus 30 degree. Minus 30 degree will be shared between 0 degree and minus 45
Sorry,
degree.
sorry, yes, sir, yes, sir, yes.
Okay, so I think clear, Shivam? This
Yes.
part?
Yes, sir, yes.
Okay, very nice. So let's move to the next thing. So we got we got for distance we have two linguistic term. It is shared between two linguistic term, that is near and far, and for this angle it is shared between two linguistic term, that is ahead and ahead right. So for this you already have this fuzzy rule given, but our fuzzy inference engine will not take all these rules in consideration. It will take only 4 rule. Which rule? We have near and far, right? So near and far. So where is near? This is your near and this is your far. Similarly, for I2 it will be ahead and ahead right. So ahead and ahead right. So only this rectangle will be considered as your fuzzy rule. That is when near will be fused with A, you will get right. Near will be fused with ART, you will get ahead. Far will be fused with ahead, you will get ahead right, and far will be fused with ahead right, you will get ahead. So this part is clear? Hello? Is this
Yes,
part
sir.
clear? Can I get response from everyone? Please write in chats. This part is clear, right? Okay, very nice. Again I am repeating, as your distance has only two linguistic term, near and far, and angle has only two linguistic term, ahead and ahead right. So all the part of fuzzy rule is not will not be fired. Only this part, and that will be shared between near, far, ahead and ahead right. This rectangle that I have marked, this part will only be used by fuzzy inference engine as a rule. So near, when near will be fused with ahead, you will get right. Near will be fused with ahead right, you will get ahead. Far will be fused with ahead, you will get ahead right, and far will be fused with ahead right to get ahead. So this is the thing. So this is what has been written here. So all I have discussed now. Now you have fused the thing, but when you are fusing this, like you are fusing near and ahead. For near you have a membership function mu and r, right? And for ahead you have a membership function mu a. So what will be mu RT? Mu RT will be minimum of mu near and mu ahead. So again I am repeating, you have a membership function of mu and R, you have a membership function of mu A. So how you will get membership function of mu RT? You will get membership function of mu RT by taking the minimum of mu NR and mu A. Is this part clear? Hello? Is this part clear? Am I audible?
Yeah. So please again.
Yes, sure. So when you are fusing a rule, you are getting a linguistic term. Now for this rule or this linguistic term, you have a mu value, that is mu NR, right? Hello?
Yes, sir.
Okay. Similarly for ahead, you have a linguistic term mu A, right?
Yes, sir.
So if you want to find linguistic term of this mu RT, the fusion of these two will result in RT, right? NR and A fused to become RT, right? So what will be the membership function of mu RT? The membership function of mu RT will be minimum of mu NR and mu A. Okay?
Yes, sir. Yeah.
Okay, so again let's see with the values. Like when you will fuse mu NR and mu A, the membership function of mu NR is 0.6571 and mu A is 0.3333. So you take the minimum of these two. So minimum will be 0.33. So this is your mu RT or alpha 1. So clear, right?
Yes, sir.
Similarly, you do this mu thing or alpha thing for all the 4 rules. There are 4 rules, right? 2 into 2, that is this 4 rules. So similarly, you find mu A, then mu A, then mu ART. So you will get this values. So after this, now when you will get these values, you move to this diagram. Like you got the first value as mu NR and A. Mu NR A is mu RT, and mu RT has a membership function 0.33. So you go to this deviation diagram. You find mu RT. So this is your mu RT triangle, right? You take this out, and now you got some 0.33, right? So it will be somewhat like this. So you take this triangle out. So this triangle is taken out, and this is your output of this NR triangle and A triangle. You get this RT triangle with this 0.33 membership function. And as your membership function is 0.33, you shade this area below it. So is this clear? Is this thing clear?
Yes, sir.
Okay, I think this thing is clear to all. So after this, what you do is you just combine the all 4 things. That is you
Compare 2 triangles, then we'll find the minimum area.
yeah. Compare 2 triangles, you got this, right? You got 0.33 as mu RT.
This is a numerical calculation and this is a graphical calculation here.
Yes. This is up to this is a numerical calculation, right? Then you go to this graph. You find mu RT is your output, right? So your input part is over. You focus on this output part. Mu RT. So RT is where? RT is this triangle that I have shaded in black. Right? This is RT. You got this 0.33 here. You take out this this thing, and you shade the below portion.
Yes, sir.
Okay, so similarly you do for the other 3 also. Very nice, right? This is clear? And then combine this 4. Okay?
Yes, sir.
Okay, so once you combine it, what you will do is you now till this we have got our fuzzified output, right? We have got our fuzzified, we have got our mu values in the graph. Now we are interested in doing the defuzzification process, and for defuzzification process, as in the last class we have discussed many rules, but out of that rule, in centroid method, this center of sum method, COS method we will apply and find the defuzzified output or the crisp output. So in this first, the shaded area is this thing. So you take the shaded area, you find the area, you find the center of the area. Center of the area, how we will find? Center of the area you will find if it is a symmetrical figure like your second figure, then your center of area will be midpoint of the two extreme ends, like minus 45 is 0. Here 0 and 90, midpoint of 0 and 90, 45. Minus 45 and 45, that is 0. But when the figure is not symmetrical, it is unsymmetrical figure, you divide this figure into two parts. You make this a triangle, and one part you take a triangle, and one part is your rectangle. You find the center of area for this triangle. So for center of area for this triangle, center of area of the triangle will be at x3 from the larger end. So here it will be somewhere like here. For rectangle, center of area will be in middle. So for that you do the weighted area method. Weighted area, how we will do? You will take A1 into C1 plus A2 into C2 divided by A1 plus so this will be your center of area for a unsymmetrical figure. Unsymmetrical figure, you will get center of area as the midpoint of your extreme ends. So by this you got area, you got center of area. Now what is your center of sum method? Center of sum method is again area into center of area, as all numerator will be area into center of area for all these four figures, and the denominator will be addition of your center of area. So you will get a defuzzified output, that is 19.5809, and this is your answer to this question. So is this clear? Hello?
So for all symmetric calculations, how to calculate
How to calculate center of area? You got area, right?
Yeah.
Area you can calculate, as it is a trapezium. Trapezium is half into height into sum of parallel sides. So area you got, right? Now doubt is center of area. So for trapezium is a combination of triangle and rectangle. So you divide this area into two parts, 1 and 2, right? So for this triangle, the center of area of a triangle is at x by 3 from a larger end. So larger end is here, and x by 3 you can calculate. So you got C1, right? For this this rectangle, center of area will be in middle of this extreme end. So center of area will be between 90 and this end. So at the midpoint of 90 and this end. So here you can find C2. So when you have C1, when you have C2, you apply this formula, that is
So,
A1.
for center of area of rectangle, 90 between what points, sir? How to get another point, sir?
How to get another point? Okay, how to get
One point
another.
is 9 and one point is 19. 19 another.
Yeah, so how you get this point? So this length, 45 and 90, 45, right? 45. Now here when you will see this trapezium is made from this triangle, right? And this triangle you apply similarity triangle rule. So you know this 0.33.
Yes, sir.
So you write this 0.33 divided by 1 equals to bottom thing, right? 45, 90 is 40. Top thing you don't know, so let it be x. This is from similarity of triangle. Got it?
Yes, sir.
So when you will get x, let x be 25. Let, I don't know what it will be high. It will be 15. 1 by 3 into 45, that is 15. So 90 minus 15 is what? 90 minus 15 is 75. So this will be 90, this will be 75. So your answer to the question is 75. Got it, right?
Yes, sir.
Okay, so you can find center of area, right? Now you can find center of area. Center of area you can find for all the point. Then you apply the center of sum method, that is COS method. COS, what COS is telling? COS is sigma AI CI by sigma sigma AICI by sigma AI. Sigma AI means you will sum all the areas. Sigma AICI means you will multiply area with the center of area and sum all. Sigma means summation. So AICI, you will do AICI for all. You will sum in the numerator. In denominator you will sum AI for all, and you will sum in the denominator, and you will be finally reaching with your answer. So your deviation will be 19.5809 degree. So this is your answer. So is this question clear to all? Can I get response? Is this clear?
So that means if you make an angle 90 degree, that will be not horizontal.
What again? Please repeat.
So the answer is 19.58.
19.58.
If you make
You go here 19.85, right? So your answer will be somewhat between this 19.8.
that means if you make an angle
हाँ,
movement of robot,
हाँ.
then it will not horizontal.
Yes, absolutely right.
Thank you.
So anyone else, any doubt, please ask. Any step, any doubt, please ask. The other 10, any doubt, please ask. Is this clear to all? Please reply in chat if it is clear. So I hope this is clear. Nobody is asking doubt. So I hope this is clear to all. Okay, so let's move on to the next sum, that is Takagi and Sugeno approach. So very similar to the previous question, here you have two input I1 and I2. I1 has 3 linguistic value, LW, M, H, and I2 has 3 linguistic value, NR, FR and VFR. LW, MH, LW means low, M means medium and H means high. And here I2, 3 linguistic value, near, far and very far. So this are your two I1 and I2, and you will have an output. So output is not given any linguistic value, because this is Takagi and Sugeno approach, that is precise fuzzy modeling. So here we don't require that linguistic terms for output. And here previously the rule is given in the form of a box. When you are fusing two linguistic term, you are getting a third linguistic term. But here, as this output value does not have linguistic term, here this is a precise fuzzy modeling, so this rule is given in this form. What does it denote? It denote that when you have A1 rule and when you have B1 rule, A1 rule is your LW, means when I1 will be LW, we will be calling it A1, and when B1 means when I2 will be NR, we will be calling it B2. Then we can get the Y thing. So if I will discuss in some time, so it will be clear. So here question asks this: I1 is given 6.0, I2 is given 2.2. So you have to find the output of the fuzzy logic controller. So is the question clear? Hello? Is the question clear to all? Are you all there? Am I audible? Okay, Khushi is telling yes. Khushi, is the question clear to you? Khushi, can you unmute yourself? Okay, question is clear to you. So I hope this question is clear to everyone. Again I am repeating, again like previous question, we have two input and one output. Here for first input you have three linguistic term: low, medium and high. For input 2 you have three linguistic term: near, far and very far. And output, you have one output, and as this is a precise fuzzy modeling or Takagi and Sugeno approach, for output we don't have any linguistic term, and here rule is given in this form. So let's move on. So I1 is given 6.0. So again you in this figure you find where is 6.0. 6.0 is between 5 and 10, that is it will be between low and medium. So again you take this low triangle, and similar to previous question you find the mu LW. So mu LW will be coming 0.8, and when you find mu LW, mu M will be equal to 1 minus mu LW. So mu LW you got 0.8, so mu M will be equal to 1 minus 0.8, that is 0.2. And for second output, that is I2, that is 2.2. 2.2 is between far and very far. So 2.2, for if we take this far triangle and do the same thing, so mu FR will be calculated and will be coming as 0.8. And similarly you can calculate mu VFR, and that will be 1 minus 0.8, that is 0.2. So up to this I think this is clear for all. This is very similar to the previous question up to this. So can I, yes, Akshay Kumar Swan is telling yes. Anyone else? Any doubt up to this? This is the ditto step as the previous question up to this. So anyone with any doubt, please ask. Okay, so I am assuming this is clear. Now we move to the next part. Move to the next part. Again, we have 2 cross 2 rules, right? For this I1, we are getting two linguistic term, low and medium, and for I2, we are getting 2 linguistic term, far and very far. So now, what we are interested in fusing this term to get output in the form of y. So this rule is given: y equals to aj I plus AJI I1 plus BK I2. So our first I1 is low, and if I fuse this low with I2 is far. So I1 is low. Low means A would be 1. So I am writing here this low. For low, A will be equal to 1. And we have second thing. Second is low, far. I2 is far. So for far is between NR will be 1, far will be 2, very far will be 3. So FR will be 2. So for FR, B will be equal to 2. So you got A, you got B, you got I1, you got I2. So you find the Y1. So Y1 will be calculated this. Similarly, you can find for other 3 things: Y2, Y3 and Y4. Now what we are interested in finding W1 or the weight of this first rule. So how we will get weight of this first rule? Weight of this first rule will be find out by multiplying the membership function of both this linguistic terms. So first linguistic term for I1 we have LW, and for I2 we have far, right? So LW and far when multiplied, that is mu LW and mu FR, that will be coming 0.64. So similarly you can get the W2, W3 and W4, and once you get Y1 W1, Y2 W2 and Y3 W3, Y4 W4, you can get the output of this thing. So Y will be equal to sigma WY by sigma W. That means in denominator you have to add all these weights, and in numerator you have to summation. You have to do summation of Y1 W1, Y2 W2, Y3 W3, Y4 W4, and you will reach this answer 12.04. So this is actually more easier than previous mamdani approach. Takagi sugeno approach is easier than mamdani approach, and this is your answer 12.04. So is this clear?
So sir, I can't understand Y1, how to calculate Y1 and Y2.
Okay, very nice. So y is given as a rule. In previous question, when we are inferring the rule, we are getting another linguistic term. Like if we are in previous example, here when we are inferring the rule, like NR and A, we are getting RT, right?
Yes, sir.
Yes, and here what you see, here you will see, here this rule is given, as this is a precise fuzzy modeling. So here the output of the rule or the inference of the rule is given in this form, right? So this is the difference between last question and this question. Up to this you understood, right?
Yes, sir.
Okay, so up to this is clear. Now here A, value of A and value of B. I1 is already given, I2 is already given. So I1, I2 we know, right? We don't know A and B, right?
Sir, I1 and I2 were given, sir.
I1, I2 given, right? 6 and point
Oh,
2,
okay. Yes,
2.2.
sir. Yeah.
Okay, so I1, I2 given, and we don't know A and BK. So our first rule is telling we have to fuse LW and FR. This is clear, right?
Yes, sir.
I1 has two thing LW and M, and I2 has two linguistic in I2 is in between two linguistic term FR and VFR, right? So in our first rule, what we will do, we will fuse LW with FR, right?
Yes, sir.
Okay, so LW and FR. So how to fuse LW and FR? Now the value of A is 1 for LW, 2 for M, and 3 for H. Okay? I
Yes,
am
sir.
again repeating, the value of A is 1 for LW, 2 for M, and 3 for H. Okay?
Yes, sir.
Okay, very nice. Similarly for B, the value of B will be 1 for NR, 2 for FR, 3 for VFR. Right?
Yes, sir.
Okay, so in first rule we are fusing LW and FR. Right? Just I have discussed how we are fusing. Right?
Yes, sir.
So what will be the value of A for LW? A for LW will be 1. So A will be 1. I1 will be 6.
6.0.
6.0. B will be 2 for FR, right? B is in between. B will be 2 for FR. 2 into 2.2. So 1 into 6 is 6 plus 2 into 2.2, that is 4.4. So 6 into 4.4 is 10.4.
4.
So clear for Y1
Yes, sir.
and clear for W1?
Yes, sir.
Okay, clear for Y1, clear for W1. Now you can do same thing for Y2, W2, Y3, W3 and Y4, W4. And Y will be summation of WY by summation of W. And this will be your output, 12.04. Okay?
Yes, sir. Thank you.
Okay, so anyone else have any doubt? Please ask. These are the two important questions of fuzzy theory application or FLC controller. And in any exam that you will be facing, you will be tested with this two sum. That I can tell you. So I hope these two questions are very clear to all. Okay? Okay, so I am assuming these two questions are clear to all, except if anyone asks some doubt, then I will clear. Otherwise, I am assuming these two questions are clear to all. Okay, so I hope these two questions are clear to all. I am moving to the next topic. Next topic is optimization. What is the meaning of optimization? Optimization is finding the best possible solution of all feasible ones. So, for example, you are designing a wooden pointer. Wooden pointer, everyone has seen wooden pointer? Hello?
No, sir.
Okay, not seen. So now when you are projecting the screen, so you use a laser pointer, right?
Yes,
You have
sir.
seen laser pointer, teachers or presenters are using laser pointer to point out a particular diagram in a slide, right? Yeah. Hello?
Yes, sir.
Okay. So earlier there is no laser pointer, so we use a wooden pointer in the form of this, in the form of cone. So teacher used to hold this from this end and they used to point. It's a long stick kind of thing. So they hold at this end and this is pointer. As it is a conical shape, they point with this pointer some diagram on blackboard. Okay, so now you understood. Now you are using contactless laser pointer. Earlier this was done by a wooden pointer. The teacher used to hold at this end and he used to point on the board by this pointed end. Okay. Okay, so this is clear now. Next thing is, yes, next thing is optimization. So if we are designing this wooden pointer, right, so there are two dimensions for this wooden pointer. One is length, another one is diameter, right? So you can have different combination of length and diameter for your wooden pointer, right? But the solution will not be optimized until you choose one dimension for your laser pointer which is the best feasible of one. So this is known as optimization. So do you all understood this? Hello?
Yes, sir.
Okay, so this is known as optimization. So let me delete it. Yeah, so mathematically what we do when we tell this optimization, we are actually finding the minimum or maximum, or we can have a third point, that is inflection point, that is neither minimum or maximum. So we are discussing about wooden pointer L. We have two dimension L and D. So now we are interested in finding out the minimum and maximum for this L and D, or there could be in between some point known as inflection point, that is neither minimum or maximum. So this is known as optimization. So how you can optimize a function, like if there is a function called y equals to fx. So how you can optimize the function or find the maximum or minimum of it? You first do simple differentiation. That is, you find first order differentiation y1, or that is will be equal to f dash x. You equate this f dash x with 0, and when you will equate this f dash x with 0, you will find a point called x star. You can find a point, or you can find it depends on what is the order of your polynomial. So you will find x star. Now you do double differentiation. And find the f double dash x star. If this f double dash x star will be positive, then your x star will be minima. Otherwise, if your f double dash x star will be negative, then that x star will be your maximum point. And another thing is inflection point. So what if your f double dash x star will be equal to 0? So at that point, what you do, you again differentiate it, again do the same thing. If
Again, sir.
hello
Again, sir.
again. Okay, so you have a function y equals to fx. This is clear, right?
Yes, sir.
Okay, y equals to fx. Now the question is, you have to find minima or maxima of this function. Okay, right?
Yes, sir.
So what you do is, you find first order differentiation. That is, you differentiate the function one time. You find
Yes,
f
sir.
dash x. Okay?
Okay, sir.
And you equate this f dash x with 0.
0.
So the answer, you will be getting some x, right? If you equate this f dash x with 0. and that x is known as x star.
Yes, sir.
Okay, up to this is clear. Now to
Yes,
test if the x star is your maxima point or minima point or inflection point, what you do is you double differentiate this function.
Okay, sir.
Double differentiate this function and put x star in that function. Like now you find f double dash x star, right? And you check the sign of this f double dash x star. Sign means whether it is positive or negative. If it is positive, then it is a minima. If it is negative, then it is a maxima. Okay? Up to this is clear?
Okay.
Now what if your f double dash x star is again equal to 0? This is the case. So in this case, what you do is you again differentiate the function. You find out f triple dash x star.
Yes, sir. Yes.
Okay, now if this f triple dash x star is giving you some value, right? It is giving some value, means it is not 0 again. It is given you positive, negative, some value. Then this x star is known as saddle point, or it is neither maximum nor minimum. Okay?
Okay.
Now you will ask again if f triple dash x star will be equal to 0. Then again you do the f 4 dash x star. Okay, again you check it is positive or negative. If in this case f 4 dash x star is positive or negative, now this is maximum or minimum.
Okay, sir.
Okay, so here what I am trying to tell you, check what is the fnx, like fn for this if fn n is your number of dash, right? You check fn x star where this fn x star is not equal to 0. You check this thing. If this fn x star is a, means if this n is a odd number, then this x star is a inflection point. Okay, inflection point, that is neither maxima nor minima. If this n is a even number, that is f4 dash x or then this is a minima or a maximum. Okay,
Yes, sir.
clear? Now let's see with this example, this will be more clear. This fx is x cube, right? We are interested to find minima, maxima or inflection point. Now we do the first order differentiation. When we do the first order differentiation, f dash x, we got 3x square. We equate this with 0. So x star will be equal to 0. Right?
Yes, sir.
This is clear. Now you do the f double dash x. So f double dash x will be equal to 6x.
Yes.
Yes. And now f double dash x star will be equal to 0. 6 into 0.
Yes, sir.
It will be 0. So
x star we assume as 0.
no. X star we are finding out, na. This step.
F dash x is equal to 3x square.
Yes. F dash x equals to 3x square because we are equating this with 0.
Okay, sir.
Okay, when we are equating this with 0, you will get some x, and this x will be equal to your x star.
Yes, sir.
Okay, so f double dash x will be equal to 6x, and again this will be 0. Then you have to go to f triple dash x, right? Now f triple dash x is a number. It is not equal to 0.
Yeah.
And what I have told here, if this n, now this n is 3, right? There are three.
Yes, sir.
So as n is odd number, then this x star is a inflection point.
Right.
Now what if same question, if we are reaching to f4 dash x is equal to something number like f4 dash x equal to 8, then what it will be?
Sir, minima.
Yes, very nice. It will be minima. And if it is -8, it will be maxima.
Maxima.
And if f5 dash x equal to 8, then it will be again inflection point.
Inflection point.
Okay, very nice. So this is clear, right?
Yes, sir.
Okay, so this is optimization problem. Now we will move to the next thing, that is genetic algorithm. Genetic algorithm is a population-based probabilistic search and optimization technique which works on Darwin's principle of natural selection. So actually I am just introducing you with this genetic algorithm. Further discussion we will do in the next class. So it is an iterative search technique, works based on probability. So up to this you have completed your fuzzy theory. Now you are moving to genetic algorithm. So genetic algorithm, it is a probabilistic search optimization technique which works on this Darwin's principle of natural selection. So what is this Darwin's principle of natural selection is, we as a animal, or we as an organism is evolving from generation to generation, and finally we are the best fit organism that is living in this world, right? This is the theory of evolution. So based on this algorithm is designed known as genetic algorithm. So working, I am just explaining you by this flow diagram. So we will start with, we will put the input data, right? So when we will put the input data, we will give some function, and by this we will generate initialize a solution belonging to you forget about generation, you will initialize solutions, like you are giving 1,000 data point, you will get, like you will initialize 100 solution. 100 is, I am just assuming, it can be 50, it can be 20. So right, you are giving 1,000 data points, and you are reaching to an initial population of solution 100, right? So after this, this 100 solution will have some fitness, like out of 100 one will be more fit, one will be less fit, one will be in between. So every solution will have some fitness score. This is the first step how genetic evolution is solved. Now this 100 solution, what they will do, they will form a mating pool of 50, right, 50 they will make a mating pool, and after making a mating pool they will do the reproduction process. So in reproduction process what will happen is, there will be crossover of genes, right? When two parents reproduce, there will be crossover of genes, means some genes will be taken from this side and some genes will be taken from this side, and finally you will be reaching to an offspring. Finally you will reach to an offspring. I hope this is clear. I am not writing it. Then what will happen is, in this offspring there will be mutation. Mutation is change of biological property with time. So this offspring will live, and there will be some biological property change of this offspring, and by this you are completing your one generation. Then you will be again adding a generation. Then this offspring will be produced, this offspring will again reproduce and follow the same process, and after many generation, or this generation also known as iteration means steps after steps is known as iteration. So after many generation you will finally reach a particular solution, that is, you will finally reach one solution, and that will be solution of your G. So is this clear?
Yes, sir. Yes.
So anyone, any doubt? I know this is a very introduction of it. We will discuss all the detail about it in the next class. Okay.
Yes, sir.
Okay, so I hope all the concepts are clear till now. Now we will be solving our assignment thing, and we will start with the fuzzy logic controller 1 and 2. Third, solving optimization problem. For this concept of GA. Based on this, our assignment will be, we will be discussing our assignment based on this. So first question, which of the application of fuzzy theory is termed as fuzzy logic controller? These are the 4 options given: fuzzy reasoning, fuzzy clustering, fuzzy programming, and fuzzy prediction. So I want everyone to write your guesses in the chat, and then we will discuss. So this we have just studied, right? Please answer, everyone. Okay, some were telling
Fuzzy
A.
reasoning.
Yes, very nice. Any other guesses apart from A? Okay, so I hope A is your only guess, and yeah, very right. Fuzzy reasoning, also known as fuzzy logic controller. We have also discussed the 2 approaches: is mamdani's and that takagi sugeno approach. Yeah, takagi sugeno approach, and answer is your A. And also I have discussed how your fuzzy logic controller works. So first question is solved. So anyone, any doubt regarding the first question? Okay, so someone's audio is disturbing you all. Okay, I think he has muted himself. Okay, no problem. Okay, so I hope the first question is clear to all, right?
Yes, sir.
Okay, so I am moving to the next question. Next question is, what is the responsibility of fuzzy inference engine? A option is convert input to appropriate fuzzy sets. Second is form the rules of fuzzy base. Third is evaluate control rule stored in the fuzzy rule base, and D is convert fuzzy output into crisp value. So I want everyone to again guess. This also we have discussed what is the function of the fuzzy inference engine. Yes, Akshay Kumar Swan is telling C. Tofan Pale is also telling C. I want others to also participate in this discussion. So please write your option in chats. Any other option apart from C? Okay, so I hope there are no other option apart from C. Anurag Raj is also telling C. Very nice. Khushi Kumar is also telling C. Very nice. Okay. So as I have already discussed, the responsibility of fuzzy inference engine is to evaluate control rule stored in fuzzy rule base. So this I have already discussed. So these are the 4 steps also I have discussed. And in third step, the use of your fuzzy inference engine, you can clearly read out the thing. And this is a very simple question. So C is your answer. So I hope this is clear to all. Any
Yes,
doubt?
sir.
Any doubt regarding this question? Please ask. Okay, I hope there is no doubt regarding this question. This is an easy question in fact. Now we will move to the third question. Which of the following statement is correct? A. Takagi sugeno approach characterized by its high accuracy and high interpretability. B is mamdani approach characterized by low accuracy, low interpretability. C is takagi sugeno approach characterized by its low accuracy, high interpretability, and D is mamdani approach characterized by its low accuracy and high interpretability. So guesses for this? Yeah, Tofan Pale is telling D. Anyone else? Yeah, Anurag Raj is also telling D. So you are telling mamdani approach characterized by low accuracy, high interpretability. Okay. Anyone else? whose answer is differed apart from this D option? Anyone else with any other option? Okay, so you are absolutely right. Mamdani approach characterized by high interpretability, low accuracy. So this is your option, and this is your correct answer. Correct answer D. So I hope no doubt regarding this question. Okay, I am assuming there is no doubt regarding this question. So let's move on to the next one. Which of the defuzzification method was used in the example of mobile robot? So these are your four options: center of gravity COG, min of maxima MOM, center of sum COS, or weighted average. So Akshay Kumar Swan is telling C. Khushi is also telling C. Anyone else? Okay, so I hope everyone is telling C. So answer is of course C. I have told you centroid, in the centroid method, center of sum method is used for your fuzzy for your that example of mobile robot problem. But again, you can also use other method like center of largest area method. You cannot use center of gravity method. Center of gravity method is applicable only for discrete input, mainly for discrete input. So that is why you can't use center of gravity method. When you have input in the form of some geometrical figures like this triangle figure or some trapezoid figure or anything, you use this center of sum method or center of largest area method. But we have not used center of largest area method because center of largest area method is not as accurate as center of sum method. So that is why center of sum method is your answer. So any doubt regarding this? So guys, any
Yes, sir.
yes. Okay, so no doubt, right? Okay, let's move on to the next question. How many linguistic states are defined for parameter angle in the Mamdani approach mobile robot? So we have two input, right? I1 and I2. I1 is your distance D and I2 was your angle, right? So how many linguistic states were there for I2? So Anurag Raj is telling D. Okay, anyone else? Anyone else? Any other guesses? Should it be A or should it be D? Okay, Tofan Pale is also telling D. Anyone else? Okay, so your answer is D. We have this 5 linguistic terms for your this input to or parameter angle. Left, ahead, ahead right, and right. So your answer is D. I hope there is no doubt regarding this. This is very straightforward, right?
Yes, sir.
Okay, so let's move on to the next one. Which of the following statement is not true for genetic algorithm? Option A is genetic algorithm, iterative process. It is a search technique. C is solution is guaranteed, and D is working cycle without convergence, with or without convergence. So anyone with any? Yeah, the solution is not guaranteed. Anurag Raj. Anyone else? Anurag is telling C. Akshay is also telling C. Anyone else? Tofan is also telling C. So yeah, solution is not guaranteed. Actually, the thing is, during optimization or such, what we are either interested in finding the minimum thing or finding the maximum thing, right? But what happens in genetic algorithm is, if your if your solution has a local minima or local maxima, then here you can see there are two minima. This is also minima and this is also minima, where f dash x is 0 for both these cases. So actually what happens is their GA poses some problem for this. So solution is not guaranteed in case of genetic algorithm. So C is your answer. Okay.
Yes, sir.
Okay, so we move to the next question. Question number 7. Which of the following is not a GA operation? Decoding, convergence, crossover, and mutation. Anyone else? Anyone with the guesses? Yes, Tofan Pala is telling A. Akshay Kumar Swan is also telling A. Okay, anyone else? Yeah, so everyone is telling A. So these are the operation of your GA operator. So I have discussed meaningful fitness evaluation, crossover, mutation. Inversion is to move from one optima to another. This I have not discussed yet. I will be discussing in detail to the next class. Convergence. Convergence, how to decide termination criteria. Termination criteria was termination criteria is evaluated by finding the G max or maximum number of generation. This is G max. Okay, sorry for this. This is G max. This is G max. So termination criteria is decided by your maximum number of generation. And so after that generation, you will be getting some result. And encoding is how to represent a solution to fit the GA framework. Encoding is basically what you do with your input processing. Encoding is not related to your GA process in general. It is related to your input processing, and after that your GA starts from 2 to 7. So out of all this 7, you can see decoding is not a GA operation. So your answer is A. So you everyone got this, right?
Yes, sir.
Yes, sir.
Okay, so let's move to the next problem. Which of the following are the minimization are the minimum operation problem? So anyone, any guesses? A is your knapsack problem, B is your traveling salesman problem, C is graph coloring problem, and D is job machine assignment problem. So everyone is telling A. Okay, so we are interested in minimization problem and many of you are telling A. So let's see the option. Actually knapsack problem is not a minimum optimization problem. Minimum optimization problem is your traveling salesman and job assignment problem. So your answer would be B as well as D. This is a multiple option problem. So this is a multiple option problem. So your answer will be B and D. So in traveling salesman problem, what you do is given a set of cities and distance between every pair of cities, the problem is to find the shortest possible route. Traveling salesman problem, you find the shortest possible route. And job machine assignment problem, you assign M jobs to N workers such that cost is minimized. So these two problems are minimization problem. Knapsack problem is not a minimization problem. Okay, so your option is B and D.
Yes, sir.
Okay, so we are on to the next one. Let the function y equals fx, degree of polynomial is m. How many points to be needed to find optima or saddle point? So maximum how many times you have to differentiate to get the saddle point or optima point? A is 2, B is m plus 1, C is m minus 1, D is m. So Akshay is telling B, m plus 1. Anyone else? Yeah, many are telling B, that is m plus 1. So actually no, the answer is D, that is m. Like you have this x square. So minimum how much you can differentiate? Minimum only twice you can differentiate to get your this optima or saddle point. If you do 3 times differentiate of x square, it will be your all of you guessed m plus 1, right? So m plus 1, if you differentiate it 3 times, so first order differentiation 2x, second order differentiation 2, third order differentiation 0. So third order will ultimately be 0. So if you will do m plus 1, it will ultimately be 0. So there you can't decide if it is your that's optima or saddle point. You have to differentiate it 2 times. When you will differentiate it 2 times, you will get 2, right? 2x and 2, yes, you will get 2. So by this you can guess if it is a maxima, minima or saddle point. So I hope the answer is clear, right? Answer is D.
Yes, sir.
Okay. So I hope it is clear to all why it is not m plus 1, right? Because when you will do m plus 1, it will ultimately will be equal to 0. M plus 1, m plus 2, it will be 0. So you can't decide it is optima or saddle point. So for determining optima or saddle point, you have to only differentiate it m time. Okay.
Sir.
Okay, so let's move on to the next question. I have discussed the maxima for the one input function, right? F x. Now, what will be the minimum value of two valued function? Here there are two inputs, x as well as y is your input. So how you will do the minimum value? How you will calculate the minimum value for this? You will do the partial differentiation for this. If you have only one variable like fx, you just do differentiation. But you have two variable or more than two variable. Here you will do partial differentiation. So what you do is you find del f by del x for this, and that will be equals to 2x plus 6. Similarly, you find del f by del y for this. So putting del f by del x equals to 0 and del f by del y equals to 0, you will get 2 points. Means 1 point, one has x value, that is 2x plus 6 equals to 0, so x will be equals to minus 3, and here 2y equals to 0, y will be equals to 0. So this x y will be, this is your actually x star. We have found out x star earlier, right? For your one input value problem. Here this x star y star is minus 3 comma 0. Now you do differentiation second time. How you will do differentiation second time? You do differentiation of this to find del 2f by del x square. That will be equal to 2. Right? Similarly, you do differentiation of this del 2f by del y square, and that will be equal to again 2. Now if we do differentiation with respect to x for this del f del y, we find del 2f by del x del y, and for this case it will be equal to 0, because if this term we will differentiate with x, this will be equal to 0. Now this del 2f by del x square is written as t, and this del 2f by del y2 is written as this del 2f by del x square written as r, this del 2f by del y square written as t, and this del 2f by del x del y is written as s. So now what we do is we find rt minus s square. Now there are these cases. If this rt minus s square is less than 0, then this is your saddle point or the inflection point. This is your inflection point. Rt minus s square is less than 0. If rt minus s square is less than 0, then this is your maxima or minima. Maxima, how it is maxima? If r is less than 0, then it will be maxima. If r is greater than 0, then it will be minima. So your answer would be equal to, when you will solve it, your answer will come as 3. So answer is D. So is it clear to everyone?
Yes, sir.
Anyone with any doubt regarding this? Again, I can make you understand. Please ask. So again, I am repeating, if anyone have any doubt. Earlier, what we did is, we do the minimum or maxima of one input variable, that is only x. Now we have two input variable, x as well as y. So here also we will start our proceeding by differentiating it. But here, as we have two terms, x and y, so we will differentiate with respect to both. Differentiate with respect to both means we do the partial differentiation. So we will partial differentiate with respect to x and find this. Similarly, we will partial differentiate with respect to y, and we will get del f by del x and del f by del y. Now we will equate both this with 0 to find the x star as well as y star, and x star y star will, you will have some point. Now you do is you double differentiate it to find whether it is maxima, minima or saddle point exists. So when you will double differentiate with respect to x, this is known as r, and you will find a value. Similarly, you can double differentiate y, so you will find a value. So this is known as t. Similarly, for this y term, you can differentiate it with respect to x also. So that will give you del 2f by del x del y, and in this case it is given you 0. Now here you find rt minus s square. This is most important, rt minus s square. If rt minus s square is less than 0, then this x star y star is your inflection point or saddle point. If it is greater than 0 as well as r is greater than 0, then it is a minima, and if r is less than 0, it is a maxima. So I hope this is clear to all.
Yes, sir.
Okay, so I am assuming this is clear to all. Okay, anybody, any doubt regarding this? Okay, I hope nobody has any doubt regarding this. We are moving to the next question. Which statement is not true for traditional optimization approach? Computationally expensive for a discontinuous function, method may fail, method is suitable for parallel computing, and discrete variable difficult to handle. So anyone with guesses for this question? Hello. So Tofan Pola is telling B. Tofan Pola is telling B. Anurag Raj is telling A. Anyone else? Akshay Kumar Swain is also telling A. Any other option? Okay, so let me tell you the solution. Actually, for traditional optimization, it is computationally expensive. When you do this traditional optimization by hand, it is actually takes time. So it is computationally expensive. So your answer will not be A, because here it is asking which is not true for traditional optimization, right? Second is for discontinuous function it might fail, because as we have already seen, we are finding the f dash x, and when the function is not continuous, it is not differentiable at that point. So for discontinuous objective function, this might fail. So this is also true. So our as not true is asked in this question, so this we are also cutting. Second is discrete variable difficult to handle. Whatever we have done for continuous variables, so this is also not this is also true, and here as we have asked not true, so this also I am cutting. So C is your answer. Method is suitable for parallel computing. Actually, this method is not suitable for parallel computing, because parallel computing means you are using 2-3 computers, and you are finding the result. But traditional optimization you only do at one place by one user. So this is not suitable for parallel computing. So as it is asked which of the following is not true, option C is your correct option. So I hope this is clear to all.
Yes, sir.
Okay. So which of the following algorithm does not follow biological behavior? So can anyone tell this? Anurag Raj is telling D. Anyone else? Akshay Kumar Swain is telling B. Anyone else? Tufan is also telling D. Okay, so let me tell you the option. Actually, genetic algorithm is inspired by your genetic evolution. So it is a biological behavior algorithm. So this I am cutting. Ant colony optimization, as the name suggests, it is linked with some biological process of ant colony formation. So again, this has some biological behavior. So this is also cutting. Artificial neural network, some of you guess this. Artificial neural network based on your functioning of brain. It is based on functioning of brain, human brain, and it is linked with neurons. So again, this is your exhibit biological behavior. So particle swamp optimization does not exhibit biological behavior. So this is your option. Option B is your answer. And other physical behavior algorithm are annealing process. It is related to simulated annealing. Annealing is your heat treatment process. And learning fuzzy logic. Fuzzy logic is also based on your physical behavior. So answer is B. So I hope this is clear, right?
Yes, sir.
Okay, so question number 13, which of the following is not a GA strategy? Simple genetic algorithm, B is cold genetic algorithm, C is steady state genetic algorithm, and D is messy genetic algorithm. So this I have not discussed till yet, but you might have read this thing in your lecture notes. So can anyone guess? Yeah, B. Yeah, Tofan is also telling B. Akshay Kumar Swain is also telling B. Yeah, so let me tell you the answer. The answer is B. The other three are different strategies of GA strategies. I will be discussing about all this in the next theory class. But till now, you just remember this, that simple genetic algorithm, steady state genetic algorithm, and messy genetic algorithm are your GA strategies. And this cold genetic algorithm is not your GA strategy. So this is your answer. So I am quickly moving on to the next problem. The analytical optimization problem falls under the category of non-linear programming method, linear programming method. C is your specialized algorithm, and D is your dynamic programming. So anyone? Okay, Akshay is telling B. Anyone else? Okay, so let me tell you the solution. So this chart you might have seen in your lecture note. So optimization problem is divided in three programming three division: linear programming method, non-linear programming method, and specialized algorithm. And in this linear programming method there are two methods: graphics method, simplex method. And what here the analytical optimization, what we are considered analytical optimization. So this analytical method falls under your non-linear programming method. So here you can see the detailed chart over here. So answer is your A. So is this clear?
Yes, sir.
This chart you can get from your lecture notes. Okay, Anugrah Raj is guessing A. Yeah, Anugrah, your guess was right. It is A. Okay, so now we have reached to our last question. Question number 15. Which of the following is not a way to represent duality principle for y equals to fx? So these are your options. A is y equals to minus fx, B is y equals to 1 by fx, C is y equals to f square x, and D is y equals to 1 by f square x. So anyone with guesses? I want everyone to guess this because this is the last problem. Please everyone participate in this. Yes, someone is telling A, someone is telling B. Here in the question it is asked, which of the following is not a way to represent duality principle? So Akshay is telling A. Anyone else? Anugrah Raj is telling A. So what is this duality principle? Duality principle is converting maximization problem to minimization problem, or vice versa. This is duality principle. So if we initially is given to maximize y equals to fx, and if we change it to y equals to minus fx, so we are doing minimization. So actually this is duality thing. So option A is not your correct answer. Again, if I am doing 1 by fx, again we are changing from maximization problem to minimization problem, right? So again B is not your right answer. D is 1 by f square x. So 1 by fx, if fx is your maximization problem and 1 by fx is your minimization problems, then again 1 by f square x is again your minimization problem. So again this is also not correct. So your correct option is actually C, y equals to f square x. So if y equals to fx is a maximization problem, y equals to f square x is also a maximization problem. It is not a minimization problem. So this is not a duality principle. So option C is your correct answer. So I hope this is clear to all.
Yes, sir.
Duality principle.
Yes, sir.
So by this we are actually ending our session. So any doubt, please ask. I know I have taken 10 minutes extra today, but that two questions were very important, I feel, for your fuzzy logic theory application, that mamdani approach as well as takagi sugeno approach. Anugrah Raj sir, how to get link of previous two lectures? Yeah, Anugrah, where you find those video link, right? Week 1, week 2, week 3, etc. Below there is a section called problem solving session. Anugrah, can you unmute yourself? Hello, am I audible? Yes, Swayam, in that NPTEL site where you find all your lectures, right? Like week 1, week 2, week 3. At the bottom you will find a thing called problem solving session, and at that you will get a link of a Google Sheet. When you will open that Google Sheet, you will find all those links, like this presentation link as well as video link also. Okay, Anugrah? Okay. Anyone else? Any doubt? Any doubt from today's lecture? I know I have already exceeded the time, but please tell if anyone has any doubt. 5 minutes, we can exceed it by 5 minutes. We have already joined, I think, 10 minutes late only. So 5 minutes more we can take. So any doubt? I am encouraging everyone. Any doubt, please ask. Today's session, any doubt you have, please ask. Okay, so I think nobody has got any doubt. So I am closing the session. Is it okay?
Yes, sir.
Okay, so thank you everyone for your patience. I hope you got something from this discussion.
Thank you, sir.
Okay, so thank you all. We will meet next week, Tuesday. Next Tuesday, same time, 6 to 8 p.m. Okay?
Yes, sir.
Okay. So, bye everyone.
Good night, sir.
Okay, very good night. Okay, bye.